Okay, today's lesson is going to be all about the power rule, which is kind of going to be a shortcut for us in order to find derivatives. In the previous lessons, you were learning all about the difference quotient and kind of differentiating from left box to right box. And now we're going to take that idea and mainly focus on the right box. We're going to just move into derivatives and how to figure those out. And the way we were doing derivatives in the previous lessons or last week really is a long way to find a derivative. So we're going to shorten that way up. And the first rule we're going to use to shorten it is called the power rule. We're going to find the derivative the old way really quick just to refresh. I'm going to show you what parts you can't really find by the shortcut way. So using this function, we're going to do our f of x plus h. So 3x plus h squared 2x plus h minus 4, and then minus the whole function, so 3x squared plus 2x minus 4, all over h, and then we're going to start foiling this. So I'm going to have 3x squared plus 6xh plus 3h squared. Just foiling this out and then distributing the 3. Distributing the 2, I get 2x 2h minus 4, and then 3x squared minus 2x plus 4 all over h. Looking for things that cancel. Anything that doesn't have an h at this point should cancel. So 2x and 2x. 3x squared, and a 4 and a 4. So I'm left with 6xh plus 3h squared plus 2h. Everybody loses an h, and my difference quotient is 6x plus 3h plus 2. When I asked you to find the derivative, you would just eliminate the h's, and so your derivative would be 6x plus 2. This guy right here is called the difference quotient. I'm going to put a little DQ there. And this is entirely in the left box. So if you wanted to find the slope of the secant line or slope between 2 points or anything, average velocity, that type of stuff, you have to have this entire thing. And the only way to find that is to do the entire difference quotient, this huge painful operation. If you want derivative, the only thing you did was eliminate the h's. You didn't repeat all this. You just used your answer, eliminated the h's, and you had your derivative. When we start doing the shortcuts, it only finds you derivative. If I were to ask you still on the test to find the slope of a secant line, you would need to do all of this all over again. There's no shortcut for the difference quotient. There's only a shortcut for derivative. So here's the short way. If you were to have some function, and I could do a little example like 3 and then x to the third, instead of doing out our whole f of x plus h minus f of x thing, what you can do is just pull the power in front. The notation is saying the n comes in front, right there, and then we subtract 1 off the end. So we'll bring this n, this power in front, and then we'll take 1 off the power. So using our example from above, just so we can see that it matches and it works, we would take this power and bring it in front, so 2 times 3, and you would take 1 off of your power, so a 1, plus, same thing here, there's a 1 on this x that you can't see, that we don't usually write. So taking that power down in front, you would have 2 times 1, and then you would take 1 off of this, subtract 1, so then you'd have x to the 0, minus, and this one is actually an x to the 0, like x is not there. So if you were to pull the 0 in front, you would have 4 times 0. So this guy is going to be 6x, and this is going to be 2. The x to the 0 will go away, and this is 0. So we just came up with the exact same derivative by doing the power rule and not having to do the entire difference quotient. And we're going to do a few more of these so you can kind of see how that works a little faster. The one thing you need to know about derivatives is if you do the derivative of a constant, like 6, the derivative will always be 0. It doesn't matter what the number is, which is what happened to us here. When we did the derivative of -4, we ended up totally canceling that off. So finding the derivative of each. And you're just going to move across the function, just doing one term at a time. When you do derivative, you kind of add a prime to it so that we all know that this is now the derivative. And what you essentially do is bring the power in front and multiply. So 3 times 6 is 18, and then subtract 1 off the power. 3 times 2 is 6, subtract 1 off the power. There's a 1 right there, so 5 times 1, and then it would be x to the 0, and I'm just not even going to write that. Next is a 6, which is a constant, so that's just 0, it goes away. And this guy follows the same rules, even though it's a negative exponent. You bring the -2 times the -4 and make 8, and then you subtract 1 from the exponent. What we'll get kids often is instead of doing a -2, they'll do a -1, or instead of doing -3, they'll do -1. So make sure that when you are dealing with a negative exponent, you actually subtract 1, which would put you at -3. We don't typically write it with negative exponents, so just doing that one little cleanup, we would do 8 over x cubed. And that's my derivative. I didn't need to go through that whole difference quotient we were doing above. This derivative, the derivative of any constant, the derivative of any number, is just 0. Next up, we've got a fraction. For right now, in the next lesson you'll learn about how to deal with fractions, but for right now what you can do is just take the x up to the top and change its exponent from a 1 to a minus 1. So anytime the denominator and numerator switched places, you just changed the exponent to either be positive or negative, and that's what we did. So that I can do the power rule only really works if everybody's sitting on the same level. I can't have any fractions. So pulling that power in front, I would get negative 1x, and then subtracting 1, I would get negative 2. And we don't leave negative exponents, so all I'm going to do is just put that down into the bottom and flip it positive. Next one is the square root of x, but that is a power of half, so I can switch it so that I can do the power rule. So just turning it into that exponent now, I can say the derivative is, pulling the 1/2 in front, x, here's a tricky thing, trying to do fractions. So you have a half and you're going to subtract 1, so leaves you with negative half, and again not leaving negative exponents. This 1/2, the 1's on top, the 2 is on the bottom, and then x to the 1/2. Doing some trig functions, the derivative of cosine and sine, we'll just stick to these two. We won't get into tangents or secant, cosecant, cotangent. So the derivative of cosine is negative sine, and unfortunately the derivative of sine is just cosine. So there's a little trick there to remembering which one turns negative. But they just flip trig functions and cosine turns negative. So just doing an example with that, you've got 6 cosine x. So to find the derivative, the 6 just kind of tags along, and the cosine turns into what we just discovered on the other side, which is negative sine. And we would probably move the negative to the front, so make that negative sine x. Just, oops, I don't need a parenthesis there. Just watch this parenthesis. If you happen to not put it there, it's going to look like 6 minus sine of x, which is not what you really mean, so just be careful of that one. Same concept here, g prime of x is my derivative. And the derivative of sine, the 6/7 is just coming along, and the sine derivative of sine is cosine. 2 more, log and natural log. The derivative of e to the x, very nicely, is just e to the x. The derivative of natural log of x, which would be this guy's inverse, is 1 over x. So you kind of just drop the natural log and then put that in a fraction. So just trying that out, again, the 3 just comes along for fun. And the derivative of natural log of x is 1 over x. And then just putting those together, I would have 3 over x. These two, I've got a 3, it's just coming along. And then the derivative of e to the x is just e to the x. That one's kind of not very exciting. Covered a lot of derivatives today in this lesson using the power rule. So bring the power in front, subtract 1 from your exponent. And then these 4 interesting cases, the sine, cosine, and then e and natural log, are ones that don't really fit your power rule exactly, but you can still find derivatives of them using their special rules.